Good evening, sir,
Yeah,
Mr.
thank you.
Ibrahim.
Thank you very much. So we're starting right away. Please, I would invite my colleague to take us through the timelines of our activity from today to for the next 2 weeks. Uh, Hawa, please go ahead.
Good evening, everyone, and welcome once again. Can you all hear me?
Yes, we
Let me
can
know if
hear
you
you.
can hear me.
We can hear you.
Okay, so welcome everyone, and
Thank you.
congratulations for taking on this step to advance your career in artificial intelligence. If you already have a little bit of experience, for those who are new, congratulations because you've also made the right decision to start your career in artificial intelligence. So welcome. So I'll be taking you through the schedule for the training, which will be happening for 2 weeks. So as we can see from our schedule here, the session will be running free from 5 to 8 p.m. So I'm going to break it down in bits. So from 5 p.m. to 5:45, starting from tomorrow, you will be having a presentation and recap on what you've learned from the previous day. And this presentation could be done by anyone, it could be called upon. So I'll advise you all to be ready and make sure you pay attention during the session so that you'll be able to make presentation and recap on the things you've learned from the previous day. So after that, we'll be moving into the first session. That's when you'll be learning new things for that particular day. That session will be starting at 5:45 to 6:45. Then we'll go on a break, a 15 minutes break to calm ourselves, take a break from what we've learned in an hour, and then we'll come back again by 7 to complete the session. Yeah, so that's how the activity is going to be from Monday through Fridays until the training ends. So on Monday, which is today, you'll be learning the introduction. You have an overview of what artificial intelligence and machine learning is. You will learn the tools and setup. You will also, I won't bore you too much with the details. Once the session begin, you will get to know all that you need to know about artificial intelligence, just a little like a breakdown of what you need to know about artificial intelligence and machine learning today. So as time progresses, you keep on building on what you've learned. So as you can see, we have an outline of the courses, particular field you'll be gaining knowledge on. So and you keep on building on those knowledge until the end of the training. So as you can see, we have building linear regression from scratch. All this might not make sense to you now, but once you begin the training, you will get an understanding of what it means and how you can use it to build stuff like that. So you get to learn supervised learning, unsupervised learning. These are all classes of machine learning. So as like I said, I won't bore you too much with the details. When the time comes, you get to understand all of these concepts. So let's moving on. So, so these are the activities for next week. These are also the aspects of the machine learning that you'll be getting to learn. Deep learning, what deep learning is. When the time comes, you get to understand that, and then you'll be building a project, a group project after you've learned, because that's like a sure way for you've actually gained knowledge, and you can put that knowledge into practice by building a project. And this will be done by group. So you'll be grouped into various groups where you work alongside your group members to come up with a project in 2 weeks. So that's basically what the training is going to be about for the next 2 weeks. Yeah, so thank you and welcome once again.
Yeah, thank you very much, Hawa, for that. Please, is there any question
Do you have
on?
any questions?
Okay,
No
thank
questions for
you.
me.
No, no questions for now.
Okay.
All right.
All right. So without further ado, we are just going to jump straight in, uh, and I'll be taking this session just like my colleague mentioned. Yeah, today we are doing the overview of what artificial intelligence really is, and we're going to be doing a deep dive into the theory, the theories of artificial intelligence, so we know what is what in artificial intelligence. That's what we're having today, and at the end of the session, we would have our basic tool set up. It's progressive as we move into the training. We are going to be setting up a couple of more tools, uh, but we'll just start basically at the end of the theory introduction. So that's how it is, and then throughout the week we are going to be introducing ourselves to practical. It's going to be very hands-on. It's going to be very hands-on. But of course, before the hands-on can make sense, you would need to know what you're doing. So it's not like someone is just putting you through what is totally strange to you. I know that this session is quite balanced. The participants, if we have everybody complete, we are still expecting more people to join in. It's pretty balanced. We have a lot of people who are highly experienced in the team. We have some professors in here. We have some people who are also quite beginners. So, and that's why you're going to be at the end of the sessions. You'll see yourself in the various groups that you belong. Please, let's take the full advantage of the 2 weeks. Let's take it very serious. It's a privilege that you have this training, and for some of us free of charge. So we shouldn't waste the opportunity. And at every point in time, please, if you have any question, feel free to stop me and ask the question. My name is Ibrahim Lukman Kehinde. I'm on Twitter. You may want to check me out, Kenny_Ivy. Of course, you can check our company's website at ksolutions.ng.com. We're a solution provider, software development, and essentially solution provider. We provide solutions to problems for government agencies, individuals, private organizations within and outside the country. We've been doing this for years. All right, so today's session is about artificial intelligence. It's a popular topic in town. Everybody wants to get involved. Of course, know a bit about it and be able to see how we can use it. And I'm sure that's why we're here. And I can tell you for free that you are in the right place to learn the fundamentals of what you need to know to be able to take your career to the next level in artificial intelligence. All right, so what do we have in store first? So we have a couple of for this background, we're going to be talking about a couple of things. The first thing is to discuss the human intelligence. because we cannot talk about an artificial intelligence without talking about the natural intelligence. So we need to talk about the natural intelligence, and then we then compare with the artificial intelligence. There's no so much theory. We are not going to bore you too much, but of course we'll speak a lot into it. And then from artificial intelligence, we then have machine learning, which is of course a subset of artificial intelligence. So we'll talk about that a little bit, and then we'll move on into talking about machine learning. So machine learning has a lot of sub branches, and one of it is supervised learning. So we'll talk about that, and of course with illustrations, and then we'll talk about unsupervised learning, which is also a type of machine learning, and then we'll talk about semi-supervised learning, which is also a type of machine learning, and then again we'll move into reinforcement learning, which is also a type of machine learning, and then finally we talk about the deep learning, which is the big deal of the machine learning actually, so which is of course a subset of machine learning. So these are contents that we've put together for this introductory section, and if you're ready, I'm ready. Okay, so what is these things about this artificial intelligence that we are hearing? What is it about? There's a lot of quotes out there, intelligent quotes about machine learning, and maybe we should be afraid, or we should take full advantage of it. Are there risk, or there's no risk to be taken? We can just do a deep dive. So Nick Bostrom stated that machine intelligence is the last invention that human will ever need to make. Of course, it's the latest invention, but the guy is also asserting that we may not even need to make any other intelligence, because this guy is capable of making further intelligence by itself. That is Nick Bostrom assertion. But there's also a fear by Stephen Hawking, who says that success in creating AI would be the biggest event in human history. Unfortunately, though, it might also be the last unless we learn to avoid the risk. So there's a lot of risk with artificial intelligence, the way we're using it. A lot of us are misusing the artificial intelligence invention, the latest invention, in a way that we are trying to replace the natural intelligence with that artificial intelligence totally. So here, and if that continues, if that trend continue, in fact, artificial intelligence can predict that the natural knowledge might also go into extinction, because there is of course what we call the law of natural selections and all of those things, that when stuff are not used, they go into extinction. So natural intelligence, from which artificial intelligence was derived, might go into extinction at some point if the trend of usage and the risk of artificial intelligence are not taken into consideration. So there's a lot of fears about on that, and of course recently there's a lot of other work going on to try and regulate the usage of artificial intelligence, and of course to make it used within the context in which it should be used. So, but that's not our worry. Our worry is to know how artificial intelligence works, and see how we can be rather than being the consumer. Of course, we're going to be consuming some, artificial intelligence product. We also want to be part of the producer. We want to know how this is done, and then we can also turn some things out and people can consume it. And this is the way to go in artificial intelligence. More researchers coming in to contribute knowledge and turning out more intelligent machine, rather than everybody standing out and everybody being a consumer. And this is what Stephen Hawking is talking about, and I'm sure that's why some of us are here. We want to know how this thing really works. Okay, before we can talk about how artificial intelligence works, I think it will be necessary, completely important, for us to talk about what is really the intelligence, that intelligence that people talk about. We need to know what intelligence is. before we talk about what artificial intelligence is. So I'll be open to hearing from anyone who want to chip in what they think an intelligence. I'm not looking for a dictionary definition. I'm just looking for a contribution, just what you think an intelligence is. Please, anybody, please. If you don't answer, then I'm going to call name. Just anything that you, Mr. Umar Abdulaziz. Do you have any idea? Okay, someone raised their hands. We have two people raising their hands. Umar Abdulaziz, I think you can go ahead. Umar Abdulaziz, can you hear me? Everybody, please, can you hear me, please?
Okay.
Yes.
Can you hear me
I
now?
can hear you now.
Yes, Mr.
said-
Umar, can you go ahead?
The question is intelligence.
Yes.
What intelligence is, right?
Yes.
The ability to work in independent.
Our ability to work independently. Yes, that's a good point.
Yes, sir.
Mr. Kevin Key Company Limited. Kevin Key or Kevin Key, right? Company Limited. Kevin Key Company Limited, please. Your hands is raised, and I'm calling you to chip in. Hello, please, Mr. Kivinsky or Kivinsky Company Limited. Please, you may turn off your mic if you are not talking. You may turn off your mic because we can't hear you. Mr. Chima, Anago. Mr. Kivinsky, I was calling you. I guess you were talking, but we couldn't hear what you're saying.
Oh, sorry. I think there was a network glitch. I had to jump off the call and rejoin again.
Okay, cool.
Can you hear me now?
Yes.
Yeah, my name is Sulaiman Olanrewaju. So, from your question, I think from my own understanding, intelligence, without the artificial word now, intelligence could mean like transforming instructions into a relatable outcome, kind of.
Okay. Transforming an instruction to a relatable outcome. Okay. Not bad. Not bad. Does anyone want to chip in? Does anyone want to chip in? Gift. Blessing gift.
Okay. From my own understanding, intelligence is knowledge. The amount or the quantity of knowledge a person has.
The quantity of knowledge someone has. Okay. All right. Thank you very much. I think someone is raising their hand. Who is that? Samuel Effiong. Please go ahead.
Okay, so for me, I feel intelligence is just your ability to gain and apply knowledge.
Thank you very much, succinct. Toyiba Olatinwo.
Thank you. Ability to change our ideas into reality.
Thank you. Succinct. Ability to change our ideas into reality. Good. I think Mr. Peter, you raised your hand the other time. You want to chip in?
Okay, sir. Good evening, sir. I would say intelligence is your ability to make decision based on predefined knowledge or the things that you would know before time.
Perfect, perfect. So thank you for that, and everybody have actually given us, very good, definition of intelligence. That at least what we know to be intelligence when we hear that intelligence. So intelligence is sometimes is misconceived to be your ability to pass tests or your ability to just read. Of course, intelligence is involved in passing, whatever tests, but it's not so. That's not sole intelligence, right? Mr. Samuel, you're still raising your hand. Do you want to still say something, or that is the hand you raised earlier? If you want to turn it so that we can keep an eye on those that are raising their hands. Thank you very much. So, intelligence should not be misconceived as just ability to pass, examinations or tests, or ability to read, and produce what you have read. It's beyond that. Yeah, I think intelligence is more about being able to gather knowledge. Ability to know how to gather knowledge, to have that knowledge, to retain that knowledge, and to be able to make decisions with the knowledge retained. So you have knowledge, and be able to apply that knowledge within context or within an environment. So sometimes you have to, when we say within context, what we are saying is that intelligence is also about knowing what to say at the right time. So if so that's about intelligence. So saying right thing at the wrong time is also not intelligent. So intelligence is about knowing how to make the right decisions, and making the right decision means doing the right thing at the right time. That is the absolute intelligence. Absolute intelligence is knowing how to make decisions, which in simple terms means you gather knowledge, you apply knowledge within applied context or within applicable, prevailing parameter or prevailing environment. That is what intelligence is. So, because if you are going to build anything around intelligence, it's important that you understand fully what intelligence is. So anything that you're going to be building should be able to do such. If you cannot define what intelligence is, so it cannot really make any artificial intelligence. So we have an Herculean task to be able to make an artificial intelligence, something that is not natural, and that thing will be able to gather knowledge by itself, will be able to retain that knowledge, and would be able to make decisions based on the knowledge it has. That's the artificial intelligence. So, of course, we have it in the material that I will show us, but without jumping the gun, I think we've been able to talk a bit about what intelligence is. Now, let me give us the literature to that. Literature. So I have this one: the ability to perceive or infer information and to retain it as knowledge, and to be able to apply it as adaptive behavior within an environment or context. This is a scholarly definition by Sharma and Radha in the article in 2008. But artificial intelligence has actually been defined way back when, but of course this definition certainly apply artificial intelligence that we have in the 20th century, because we have a lot of breakthroughs in the 20th century. There's a lot of disappointment in artificial intelligence research. That's at some points people were giving up as to, can this thing really live up to the expectation? Well, in the mid 20th, in the 20,000 from 2005 till date, we had a tremendous progress, and that's why I think some of us are now coming into it and then hearing the boost. But artificial intelligence has always been around. So, for literature's sake, you may want to keep this definition, but of course, what is most important is to know that artificial intelligence is about acquiring knowledge, retain the knowledge and be able to apply that knowledge in the right way at the right time. So that is what intelligence is. Now, now that we know about what intelligence is generally, whether it's human intelligence or artificial intelligence, that intelligence is general. Now, it's important for us to talk about the human intelligence because the model, of course, the people who are developing artificial intelligence are human, and we can only model artificial intelligence around what is existing, which is human intelligence. But human intelligence is not the only intelligence available. But human intelligence is the most evolved intelligence, from the fish to to amphibians to reptiles, all those ones like that. So what we have now, human intelligence is research shows that human intelligence is superior to any other intelligence of beings. Of course, the ones that we know on this earth. Okay, so, and it's important to now see how human intelligence work so that we can build a machine or an artificial intelligence to work in similar ways. Right? So it's our job becomes easier once we can model something around that line. So how human work is, first of all, we will gather information. This is how our brain works. We gather information either by conscious or unconsciously. We gather information. We gather information consciously by just like the session that we're having now. Everybody came into this session wanting to gain knowledge. This is a conscious knowledge or data gathering. Sometimes we gather knowledge by accident or by unconsciously. What I mean by that is if you stay in an environment and then you continuously expose yourself to certain type of data, even though you are not intentionally receiving that data, but whether you like it or not, that data is coming into you and you're having it, and then that would inform how you act and behave. Of course, that would affect or influence certain decisions that you make, even though those informations you gathered are not consciously. All right. So human brain or human intelligence work by first gathering data or gathering information, depending on how you're presenting that. So when we gather information, sometimes we may choose to not save it in our memory, but of course, naturally, as soon as you are receiving that information, portion of that information gets saved by default. All right. So, but sometimes when we gather information, either consciously or unconsciously, we begin to analyze that information. So you analyze the information, and depending on your bias, because bias will come in now. When you receive an information, there's a bias there. The sentiment to which you receive that information, if the information appeals to your bias, you take it faster, and that would influence how you analyze that information. So you analyze information, whether with a positive or negative bias, and then you have that information, you save it selectively. You have that information stored within your memory, and then once you have that, you make decisions. Decision making and taking action is pretty much interwoven. Taking actions and making decisions. So when you make a decision about something, it is not necessarily natural that you've taken action about it, but you've decided that you are going to do that thing. Then when you make a decision, that's when you killed it entirely. Just like maybe some of you register for this training, at that moment you decided that you're going to attend this training, and then now attending this training is taking the action. All right. So also human intelligence has a very big ability to be able to retrieve information stored. But of course we cannot retrieve everything that we saw, but of course we can selectively restore certain information that human stores. All right. So this is how human brain works without any, we are not putting it in one line. It's not a queue kind of structure because human brain is so complex. So we work sometimes we take action before we even think, and that's why you're saying that we are not necessarily saying that gathering information comes before taking action. So because this is how human intelligence work. Sometimes we do this without necessarily following any order. All right, but the natural way, if we are going to build a model, it has to be systematic, because this is how system work. So if we are going to build a system, there has to be input first, and then there will be processing, and then there will be output. This is how system work. So if we are going to build a natural intelligence, an artificial intelligence from the human intelligence, so we may not be able to just do the random ways of human intelligence, but of course we can do the straight line way of getting information, processing that information, and then taking action based on the information processed. All right, so this is how human intelligence, this is just a schematic diagram of human intelligence, and this is also a scholarly article. It's not just something that comes out of the blue. Okay, so a lot of researchers have worked on intelligence or especially on human intelligence. So there is this man also who did some work, Howard Gardner. So he categorized human intelligence into 9. And he spoke into it like this. So he said human intelligence, you can have naturalist human intelligence, and that is understanding living things and reading nature. So human intelligence has the ability to understand, other living things and be able to read what nature, that's the nature around us. So ability to do that will mean that we can say that human is intelligent. And this is if someone is trying to measure intelligence quotient. When someone was giving his own point of definition, he said the quantity of knowledge someone has. So if you want to go by that definition, so you want to measure how do you quantify knowledge? So you may come from Gardner 9 intelligence quotient. So you may want to maybe you gather human, and when you gather them, you try to see the ability to understand other living and ability to perceive nature. So you can get that intelligence quotient from this 9 categorization. So, and that we equally have body kinematics, which is ability to coordinate your mind and your body. So you see that the highly intelligent people are very coordinated. That's because they know how to control their emotions, and then they know how to take the right distance. So human intelligence can also be can be measured based on your body kinematics or kinesthetic, depending on how you call it. So we have musical, you have logical, mathematic, ability to sense, interpersonal, be able to perceive what is going on with other people without necessarily, without them telling us that what is going on. So we are able to, perceive what is going on within our surrounding, and of course linguistics. People have said that your ability, your choice of words also speaks to the intelligence level of human. So this is how this Gardner has categorized his own. It's not like everybody agrees with it, but the majority of researchers along this line agree that of course this can be intelligence quotient can be categorized like this: ability to be able to know musical tones. Some of us who are not into music may not know what musical tone is, but of course the musical tone doesn't necessarily have to mean that, mean we understanding that what tone is pressed or something like that, but ability to understand that when you hear someone's voice, ability to be able to tell that this is the guy speaking without even seeing them. This falls under here. For some of us, if we had an encounter with someone before, human intelligence is able to decipher even without seeing that. We can know that, okay, this is the guy talking. So not necessarily music, because if you have not trained yourself in music tone before, of course you won't know which tone they're talking about. And so that this is a bit of the 9 categories of intelligence. I'm not going to bore us on this, uh, but of course, if you have questions later on, we can ask. Of course, even if we have right now, we can ask. Now, human brain, um, behind the natural intelligence that we are talking about, the human intelligence that we're talking about, is this gigantic feature called human brain. So human brain controls what we do. Of course, basically everything that we do, how we see, how we react, and of course how we consume knowledge and how we apply that knowledge. Human brain controls everything. All right. So, and until we had an invention that looks like human brain, we did not really have make much progress in artificial intelligence itself. All right. So, human brain is the most complex object. This is what has been proven. The most complex object in the world. So, if you have seen like a power station before, you get to see a lot of connections and disconnections and all, and you wonder how this interconnects and how this works. But human brain is even much more complex than that, and this sits on our shoulder, and this is what you and I carries away. So this is a mystery in human brain that research has been ongoing to uncover the mystery of human brain, and it's still ongoing. And so we've not been able to uncover everything around the human brain. But of course, with the little that we know about human brain, this is what gives the latest, advancement that we've got in artificial intelligence. All right. So human brain is made of neurons, billions of neurons, like 100 or 10 billions of neurons you can have, depending on the shape or size of your brain. And of course, these neurons are interconnect. So before Kenny sees, there's a lot of neurons we communicate with one another before human sees. By Kenny, I mean me. I mean myself, right? So before you talk, there's a lot of interconnections, a lot of activity going on within the neural system before we take or see or perceive or do whatever it is that we do. So this guy is the engine room, is the back end, of the whole human coordination. And of course, Michio Kaku, boastfully says in his article that this is the single most complex creation in the universe. Nothing comes close. Okay. Now, enough of talking about the natural intelligence. Since we are not here to talk about natural intelligence, or we're not neuroscience or neuroscientists. We are not neuroscientists, but of course we are, technology enthusiasts. So we know a bit of the natural intelligence, which makes us then understand before, which then make us understand more what artificial intelligence is. Since we now know what natural intelligence are. All right, so a lot of us have been hearing about artificial intelligence, and all those things like that. So here we are, being, ready to build our, first. Some of us, I know that some of us have built, based on my interaction with some of us. Some of us have built an AI before, maybe even as minimal as it is. But for a couple of us, majority of us, maybe after this session, by next week, we'll be building our first AI. Now, so I would want to also ask us, in the spirit of ensuring that everybody here is alive, I want to know if anybody can tell me, beyond what you're seeing on the screen, beyond the definition that you're seeing on the screen, if anybody can throw light, when you hear artificial intelligence, what comes to mind? Just like we define the intelligence, I would want to hear from us artificial intelligence. Each time you hear this, what comes to your mind? Anybody, please. Blessing, please go ahead.
Okay, whenever I hear artificial intelligence, the first thing that comes to my mind is robotism.
Okay. Okay. All right. So how do you, what is robots in your own estimation?
Is a programmed um is a programmed machine that has given a certain information or code to perform a certain function.
A programmed machine that is giving an instruction. Can you say that again?
Is a programmed machine that has been given a certain information or code to do a certain function.
Okay. Thank you very much. Thank you for that definition. Good definition, by the way. Mr. Chima.
Thank you, sir.
Mr. Chima Nago, please correct me and let me have
Mhm.
the right pronunciation.
Yeah, evening, Mr. Lukman. Evening.
Good evening.
Can you hear me?
Yes, I can hear you.
Yeah. Okay, you are correct. That's Chimanado. Well, when I hear artificial intelligence, first thing that comes to my mind is robots, like Blessing said. And as you asked, what are robots? Robots, I can put in my own definition as machines built by men in order to help men to accomplish certain tasks. And those machines have been given some level of intelligence in terms of softwares or programs that have been.
Okay, can you summarize? You said so many things. Can you summarize it like in one sentence? Yeah.
Machine built by humans to help them in solving a particular problem.
Okay. Machine built by human to help them solving a particular problem.
Yes, to help you. Yes.
Okay. Okay, thank you, Mr. Chima. Good contribution. Please, does anyone want to chip in? Samuel Effiam. Samuel Effiam. Okay. Akpan, go ahead, please. Akpan, are you here? Not necessarily just a contribution. Samuel Effiam, it looks like. Can you hear me? Samuel Effiam, can you hear me? Sorry, I was talking and nobody heard. Samuel Effiam, can everybody hear me, please?
Yes, I can hear you. I wasn't hearing before.
I can hear now.
Yes,
Okay.
I can hear now.
All right. Okay. Thank you. Samuel Effiam, please go ahead.
Okay, you were asking a definition of artificial intelligence.
I'm not asking
For me,
definition per se. Okay,
I'll
yeah. Just tell
okay,
us
like
what you know.
like for us,
Yes.
what we understand by it.
Yes.
Okay, for me, I'll just say it's like the smartness of computer systems. That is its ability to take in a certain input from a human and deliver a desired output.
Okay, yeah, without wasting more time, thank you very much, everybody, for that contribution. I think we'll move on from here. So, the cognitive behavior of human ability to teach system, or let me remove the teach from there. Ability of a machine, artificial intelligence, ability of a machine to wear or have the cognitive behavior of a human. That is artificial intelligence. The cognitive behavior of human. You know, we define what an intelligence is, and we spoke about the human intelligence. So if a machine is something that is not natural, if it can have a bit of what human intelligence have, then we will say that machine is intelligent. If the machine is able to retain knowledge and be able to apply that knowledge and make decisions with that knowledge, then that machine would be termed as being intelligent. And when I say cognitive behavior, you know, the cognitive behavior of human be able to talk, you know, so we see that machines are now talking, be able to hear, you know, machines are now receiving, you know, language as inputs, and be able to process what was heard and make decisions based on that. You can now speak into machines and ask that machine to do certain things, and they will be able to do what you ask them to do. So it means they are making decision. So if a machine is able to do this, then we'll say this machine is, you know, is intelligent, you know. And so because it's a machine and it's not natural, of course it's artificial. So any intelligence that is not natural in terms of maybe human or any of the mammals or any of the animals intelligent, if it is artificial, like it's man-made, anything that is man-made, of course, is artificial, then we would say that, you know, it's an artificial intelligence. So what we are trying to achieve is a world where we will need less of the human intelligence and use more of the artificial intelligence. You know, for some reason, some of the artificial intelligence, some of the natural intelligence are not available. You know, and if they are available, maybe the real intelligence are very, very expensive, you know, to come by. All right, so it will be nice or good to have someone by your side who's like an expert who can guide you. And that's why you can see that a branch or application of artificial intelligence is what we call the expert system. And I'm currently also working, you know, and doing a lot of research on that expert system, which is replacing human experts with machine experts, and which is of course a subset of artificial intelligence. I just send email to I share email to I send email to everybody. That's all right. So that is basically what that is. So if you look at what we have on the screen, a couple of people are saying that they did not receive our email, which was sent last week. And I think we are supposed to share this on the social media so that people can the link, but of course it's not for everybody. It's a lot of distance. So of course we hope that they will be able to catch up tomorrow. Today is just laying the background for what is to come tomorrow. All right, so basically artificial intelligence is talking about the intelligence of machine or software. So it doesn't have to be hardware, it could be a software. When we talk about hardware, we're talking about robotics, and robotics also can also work with, you know, an inbuilt software. So as opposed to the human intelligence, is basically what artificial intelligence is about. So if anybody has any question, please feel free to ask. Now, the real question comes: human intelligence versus machine intelligence. Which one is more? I was watching something on social media on the channel of artificial intelligence channel, and you know, and it was I saw where a human expert in ping pong, that's table tennis, being comfortably beaten by a machine, a robot. but who's just artificial, comfortably beating uh, an expert. Imagine someone, an artificial intelligence beating a Roger Federer. Uh, so that is artificial versus human. So I would also want to hear from us, from our perspective, human versus machine. Which one is superior, and which one is more intelligent? I think it's a stupid question, but let's explore it. Let's explore it. So this session is going to be very interactive. So I'm going to be asking you a lot of questions. So, Madam Toyiba Olatowo.
Sorry, you asked a question now.
Yes, I was asking you human versus machine. What can you say? Which one is more intelligent? Which
All
one?
right.
Yes.
Sorry, can you take the question again? Sorry.
Yeah, human
Okay.
versus
About
machine.
human versus machine.
Yes. Which one is which one is better in terms of productivity, in terms of
All right.
output?
Um, in terms of productivity, I think machine intelligence has a higher productivity than human intelligence
Okay.
because human intelligence tends to fluctuate,
Okay.
but machine intelligence tends to act according to what you have programmed it to work for. So that is what I feel about machine intelligence.
Okay, thank you very much. I think that's a very good submission. Human intelligence fluctuates, but machine intelligence doesn't fluctuate. Good. Uh, Mr. Akpan.
Yes, I think it depends on the application of human intelligence versus machine intelligence. For example, human intelligence could derive inspiration from something random, something from another experience entirely, but machine intelligence works only based on the information it has learned or the information it has been given. So I think in certain aspects, machine intelligence may be somewhat limited, but human intelligence may be able to, transcend and get ideas from so many different places. Well, machine intelligence is quite better in the fact that it has access to this large pool of information and has the ability to come up with ideas and give a large amount of information in a small amount of time. So it's depends on the application really. Yeah.
Thank you very much, Mr. Akpan. I think you summarized it. I want to hear more opinion though. Adenike Majinat. Adenike Majinat. Are you here?
Yeah, good evening, sir. I'm sorry, I'm on my way home actually. I don't know if you can hear me.
Yeah, yes, we can hear you.
Okay, so I feel machine intelligence actually supersedes like they are more intelligent than human.
Okay.
And yeah. Uh,
Okay. Machine intelligence is more important. Is more intelligent than human. Good. All right. Thank you for your submission. Uh, I think we've had Mr. Chima. Mr. Kibu Amakalo. Okay, Mr. Peter, you want to talk? Please go ahead, Mr. Peter.
Okay, sir. In terms of efficiency, I think machine intelligence is way higher because it's rarely or less affected by environmental factors and the likes. So it is possible that human intelligence is affected by the length of their day, their tiredness, and the like. So there's a very high chance that machine intelligence is going to give a more efficient output than human intelligence. I think where human intelligence like has a little bit of edge over machine intelligence is where emotion comes in, emotional intelligence. The fact that machines cannot go all the way to know how you feel and the likes. But aside that, machine intelligence has a leverage, a very high leverage over human intelligence. Plus, it's a coming together of many human intelligences in quotes now to make up one body of knowledge. Thank you, sir.
Thank you very much, Mr. Peter. I think that's a very good submission. Does anyone want to chip in any other thing before I open it up a bit? So Mr. Peter made a point that machine intelligence is not emotionally intelligent. Beyond that, that machine intelligence is not affected by environmental factors, a couple of distractions or prevailing distractions. It is doing what it needs to do. Of course, you just get on doing what it needs to do. But isn't that also part of what we are talking about intelligence? Being able to, if there is certain context that you shouldn't work, maybe you should not work. Like, artificial intelligence is also street light falls under the artificial intelligence, the street light that you see. So, artificial intelligence, that's part of the artificial intelligence. So this guy passes us once we get to that traffic light, we wait, and then shows red, shows green, like that. So but on a weekend or even the normal, when there is no traffic any other way, this guy would just still keep you waiting when there's nobody coming from any other direction. Human would have looked at the prevailing parameter and say, okay, go ahead. Of course, that goes with what Mr. Peter is saying. So I would summarize my submissions after comparing the two. After comparing the two, intelligence. So machines are better than human in this following. In terms of alertness, in terms of getting ready, machine intelligence is better in terms of alertness, like on your track, get set, go, or something like that. Yeah, in terms of what you are expecting, when that thing comes, you take it and then you walk. So human can be carried away. We can have upset minds and all of those things. This doesn't happen to machine. As what they're expecting, as soon as what they're expecting comes, they take it. They don't make a second of it, and then in terms of alertness, they are way better than us. Artificial intelligence is also the advancement we have in cars, in planes, and all of those things. Of course, in mechanics, in automotives, and all of that. So this is also part of artificial intelligence. So we have car, we have all sort of the plane system that we have. These are speed. Human intelligence cannot dare to compete with machine in terms of speed, in terms of the mileage coverage, and in terms of the speed of execution also, beyond the distance covering. In terms of speed of execution, human intelligence cannot compete with the machine intelligence. It's like how long it will take to, for instance, break down the particular mathematical equation. Human intelligence will walk straight line, 8 plus 2, this is like that. Even though machine intelligence will also go through that, but it goes through it in a microsecond and it gives you the answer before you even pronounce before you even finish putting in the question, the answer is already out. So we cannot there compete with machine intelligence in terms of speed and power. So no. So that's also there. So in terms of sensor detection, so this we have to say this third one with care. In terms of sensor detection, we have to say it with care, because human is better receptor of sensors than machine. But we have a range, we have a limit. Human have limit. We beyond certain limits, we don't function. We don't know what is going on around us. Like maybe I'm upstairs now, I don't know what is going on downstairs. But machine may be able to cover more distance than we do. So in terms of censoring, whatever it is that we need to censor, human is better within certain range. But outside that certain range, we are clueless. We don't know what is going on, and so machine can be able to have that. So sensor detection outside human range, machine is better. Routine tasks, in terms of repetitive tasks, in fact, humans are very lazy in terms of this. In fact, some of the most intelligent people hate to repeat things. So if you're doing some sort of things over and over again, it gets boring and you don't want to even do it again. But even if those are not smart and all of those things, humans repetitive tasks, machine can do the same thing for the next 10 years, just doing routine works like that, up and down, just going up and down like that. Machines are quite expert in that. We cannot dare to compare with them in terms of computation, which goes with the point 2. Human beings are very limited in terms of computing power. Short-term memory also. We have to talk about memory with care also, because machine is limited by by infrastructure that is powering it. For whatever machine that you're seeing, like a ChatGPT, has some data that is backing it, that is making it behave as if it's a god, but it has a storage of data that is backing it. All right, so it's limited by the storage of that infrastructure that its data is sitting on. All right, so it means there has to be purging at some point, or doing some type of randomizing and all process at some point. And so we are talking about in terms of such short memory that machine is able to contain. Machine is better in terms of memory retentions and retrieval than human. All right, and simultaneous activity, in some of being able to do so many things at a time. Women, not human now, women, have given themselves specific title, a multitasker. All right, with due respect to all human here, all women here. All right, so but they cannot do 1/50 or 1/100 of what machines can do simultaneously. Machine can do 1001 thing at a time, and all of them with precisions, with accuracy, and with speed, and with power. Machine is capable of doing that. We cannot dare to do that. So in terms of this summary, machines are way better than human would ever be able to do. So, but human brain has its own distance, of course, because machine intelligence is carved out of human intelligence. So beyond the physiology, sensory functions, we are very sensitive in terms of we can read what people are thinking. Sometimes it can be wrong, but we can read even without people talking. We can read environment, read mood, we can read all those things, and know what is going on. So human have an exceptional sensory functions. Perceptual ability, which is also very related to this one, we can read perception. And like I said, most of our perceptions based on our bias may be wrong, because perception is based on bias, may be wrong, but we have that capability that machine don't have. We can perceive stuff, and then based on what we perceive, we can make decisions based on that. Flexibility, we are very flexible. We can bend rules. Machine don't bend rules. They follow the rules strictly as we are given it. Even if the president of the United States, if you say nobody should pass, machine doesn't know that. Nobody will ever pass. But human, you can say, okay, bend rule for these people because they are, government officials. Bend rule for these people because they are authority. Bend rules for this. Of course, you can also train machine to also do that. This is what machine learning comes to do. And machine learning is very, very different from classical programming. Those of us here, I know a lot of us here are programmers. Machine learning is very, very different from classical if-else statement. In terms of judgment also, human being is very, very superior. We can judge, we can make judgments, and our judgments are superior. Machine will make judgment based on the original data, the data that they have before. But we can also be able to make certain decisions, even in fact we have not, we can make certain judgments even if we have not encountered such this thing before. So we can judge between what is right and wrong. So human, God has given us that innate ability to be able to do that. And of course, we have selective recall activity. Selective recall activities in the sense that sometimes we don't know how our brain works. Sometimes we don't even know what we know until we are faced with something that requires us to pull off that knowledge. And that is when that thing will activate itself, and then you pull it off. That selective recall, sometimes it looks like that knowledge is dormant, but the moment you're faced with tasks that requires that everything just get activated, and then you pull off. And of course, sometimes selective recall can also be explained in terms of our brain has a way of working in a way that we choose what to remember and what not to remember. In a way, we control that by how we act and act on information. I mentioned earlier that one of the risks of artificial intelligence is the way some of us are consuming artificial intelligence, that each time we need to do something, we just run to this guy and be asking this guy. And this guy intelligence, of course, is based on data. Now, and this data is being generated from somewhere, and people are coding that in. Imagine all those guys who are behind the artificial intelligence. God forbid something just happened and everybody are cleared up. So we don't know how this thing works. We don't know how to manipulate or do a better stuff than that. And then maybe we've successfully do that, and then we build generations of people who don't even know how to even do manual stuff. Their whole life is to always run to an AI to do stuff for them. Knowledge will eventually go into extinction, because when you don't use brain, it just doesn't develop. So just explaining selective recalls, based on certain things that we work on frequently, our brain tend to retain those data around that. That's our frequent activity. And of course, we have inducive reasoning. We can induce based on certain things. We can put one or two together and make a data out of it. So, and that data maybe doesn't exist. I can say, if this guy can do this, then he can also do this to this guy. If he can do this guy to this thing to this guy, he can also do that to me, or something like that. So human have that inducive reasoning that machine doesn't have. So generally, machine doesn't have the human capacity. It cannot. It doesn't have that. It doesn't have the human intelligence capacity. So in terms of intelligence, the human intelligence is far, far superior. It's far, far superior to the machine intelligence. But in terms of mechanical intelligence or mechanical activities, we see most of the where machine wins in terms of mechanics. And if that mechanics also fails, it's a problem. It's grounded and all. What human intelligence is a mystery. Even us, we don't understand our intelligence. And like I said, researchers have been working on it for years, and we still don't know the extent of our intelligence. So human intelligence is so complex that machine intelligence does not match half of the human intelligence. But in terms of mechanical intelligence, of course, we don't have that ability. We cannot match machine in that line. So if anybody wants to chip something in, please feel free and chip it in. Now, in the next 2 minutes, we'll have a mini break so that we can reconvene, just to have I know a couple of us are adults. It's just have some break and stretch leg, take water, and come back. But before then, I would like to entertain any question that you have so far. Please, I'm listening. Please, am I audible? Please, can everybody hear me?
Yes, sir.
Yes, I can.
Okay. So if there's no question, would have a short break. We'll reconvene by 7 to continue, so we can have our freshness regain and we can move on. Thank you very much for listening. All right, so welcome back. Let's flow on. So earlier on, we started by talking about introducing ourselves to the concept of artificial intelligence. So we explore the definition of intelligence itself, talking about ability to be able to gather knowledge, apply that knowledge, and make the right decision in the right context. And then we moved on to talking about the human intelligence, where we explore the various ways in which human intelligence work, how we gather knowledge, how we retain that knowledge, how we make decisions based on the knowledge retained, how we take actions based on the knowledge retained, and all of that. So we explore all that about human intelligence before we moved on into talking about the artificial intelligence, which is what we are here for. So we compared the human intelligence to the artificial intelligence, and we came to a conclusion that for some activities human intelligence is superior, and for some other activity in terms of speed, sensories detections beyond human range, computation power and all of that, we said that machines is better. But we talked about in terms of judgment, perceptual ability, selective recall, inductive reasoning, that human is better. And so generally we said that human brain or human intelligence is a mystery that for now machine intelligence that cannot match it. But of course there's a lot of work going on to try to outsmart the human intelligence, but it's going to take a whole lot. To be able to do that, because you have to know the extent to which human intelligence hands before you're able to surpass it. But of course machine has surpassed it in terms of mechanical powers. All right, so moving on now, let's talk about the artificial intelligence timelines. So a couple of us, when we hear artificial intelligence, it looks like something that just happened yesterday. Most of us, our mind is fixated to ChatGPT, as if there hasn't been any artificial intelligence before then. And ChatGPT is something that just happened last year. And Google made their own version of the GPT this year, which is March this year. So Google's version of ChatGPT is not older than 6 months. So majority of us, when we look at AI, we just look at it with that prism, with that very myopic prism of just looking at what has happened recently. But of course, artificial intelligence has been around for only God knows when. So from the days of Aristotle and all of those things like that, they laid the foundation for the artificial intelligence. So it's important that we know a couple of this background, even though we may not be using it, but of course it's important that we know when a couple of those things that came together, and then that give results or give that produces the artificial intelligence that we now enjoy. Okay, so the foundations of artificial intelligence are from the philosophies, from the economics, from the mathematics, from the logics, from the controls, all those things like that. All those subjects laid the foundation for artificial intelligence. So in 1642, of course, we have first mechanical calculator that we have, calculating machine in 1642. But even before then, there has been, the foundation subjects like philosophy, like mathematics and all of those things that laid effectively laid foundation for that calculating machine. So we would say that those subjects also contributed. So artificial intelligence started when those subjects were started. But of course we have advancement in 1642, 1837, all these things. You're going to get this slide, so I'm not going to bore you talking about them. So significant improvements or progress were achieved in the 1950s. All these ones, 16th centuries, 18th centuries, 19th centuries is when we have significant, especially in 1950s. The first real intelligence we have Alan Turing, which was developed to be able to check and test the human intelligence. So a template was developed to be able to see if we are going to say something is intelligent, there has to be something that we use to test it. The Alan Turing itself gave birth to the modern artificial intelligence that we have today. So in 1955, AI was officially born. But like I said, of course, it has grandparents, dating back to the days of Aristotle and all of that. So in 1955 and 1956, 1957, officially we have AI born. Was discussed officially in a seminar, and then that's when there's a forum of researchers or scientists gathered, and then that's when they officially talk about the artificial intelligence. That subject came out, and then it was stamped. From then on, the rest is history. Of course, there has been a lot of disappointment even after then, a lot of turbulence, a lot of hope going down, like maybe would this thing ever live up to expectation, until recently, where we have in the 20th centuries, where we have artificial neural network. So artificial neural network has actually been developed in the 1950s as well, but then we don't have the computing power to be able to power that. All the computing power that we have back in the days, maybe 256 MB, 256 like that. But recently we have high computing power to be able to power neural network, artificial neural network, because the real intelligence cannot happen until we're able to simulate the workability of the natural human brain. And the natural human brain works with neurons. So scientists in the 1950s developed artificial neural networks, but then we don't have the machine, the computers, we don't have computers capable enough to do those computations, to be able to turn on the interaction between 10 billions of neurons. It's not possible. Not until 20th centuries or the late 19th centuries, 1990 thereabout, that we had that computation power, and that is why now we have a lot of advancement thanks to the neural network. All right, so in the 2009 we have this Google built their self-driving cars, which is very intelligent enough that it can navigate the town. You can send that self-driving car to a supermarket to go get something, and then you can send a self-driving car to school to go pick your kids. You can. I bet you can try it in this climate. But of course, you have what we are talking about in terms of intelligence, being able to navigate, to go from one location to the other without having an accident in terms of heat itself, having that maybe colliding with an object or colliding with any other. So he's able to sense when there is an approaching object, and is able to navigate around that and then to its destination. So it was built, and it's also able to resist obstacles, resistance, and physical resistance as well. So that was celebrated in 2020, 2009, 2010, 2011 thereabouts. And then in you have in 2002 where we have High Roberts launched by Ramba, and all of those things like that. This is where we have real intelligence. The intelligence that we've got before were pretty much like we are playing, so this is where the hope really came up from the 1997. That's when the hope really came alive again. And most recently, all through 2018, most recently last year, we had a breakout from the OpenAI. They introduced what they've been working on. They've been working on it for a while, but it was officially launched last year. Just last year, we have that GPT. But there has been GPT-1, GPT-2, GPT-3, but there's GPT-3, GPT-4. Where we have a lot of advancements where you can have a conversation, with an AI, and AI is able to reason pretty much like human, make decisions, and able to get and gather knowledge on its own, and then make that decision. And this year, the Google Bard, effectively just shut down the ChatGPT, because what the capability of that is way more than the ChatGPT. But what is more exciting is that a lot of work is still ongoing. So next year we are going to have a lot more coming into stream, and some of us, it's a time that some of us would need to also get in, because it's an exciting time. The research is open, and some of us can at least get our hands on some research that would help change this world. And I'm happy that we are here to learn how these things work, and possibly see how we can be part of the history. The artificial intelligence is not as difficult as it's seen, as most of us think, because we imagine it. It's quite simpler than it seems, because a lot of work has been done. So all you need to do is just build on existing frameworks, existing work, and extend what has been done. A lot of work has been done. We don't have to reinvent the wheel. We just have to extend what is there. So in this timeline does not capture GPT, and of course the latest achievement by Google. But of course, like I said, a lot is ongoing. Next year there will be so much more in the stream, so we can only be excited about what lies ahead. Like I said, this is the right time to get into the timeline as well. So you will have this list slides. You can take your time to go through each of the timeline, and also do a bit more research. They come with interesting stories. Each of these timeline come with very interesting stories that you may want to. So, but this session is not to bore you with storytelling. We are here for practical, like I mentioned. So, getting into a bit of work. Now we've looked at the timeline, how AI started, where we are on AI. I told you the latest developments, high development, or huge success. I would say it's what Google has achieved, but there's a lot going on in MIT as well. Now, so let's look at AI at glance. Most of us, when we hear about AI, we are a bit confused, and we mix a couple of these terminologies together. We are not sure where what belong. When we talk about AI, is AI robotics? What is machine learning? What is deep learning? A lot of terminologies that we don't really understand. So it's important. This is the context that we're going to put everything into perspective, and we should be able to, from now going forward, we should be able to understand one terminology, at least to an extent, from the other. We should be able to distinguish which of these terminologies from the other now. I'm sure that most of us have heard machine learning, and sometimes we don't know the difference between machine learning and deep learning. We don't know the difference between artificial intelligence, robotics. Everything is just coming together, so we don't know what is this about. Now, artificial intelligence is a field in itself, and we can say it's a field of data science. And data science in itself is an interdisciplinary field. It's not just one field. There's several fields come together when we are talking about data science. We have the computer science, we have the mathematics, we have the engineering, and then of course we have there's always a domain of knowledge. Now, so when we say domain of knowledge, is when we say we are developing artificial intelligence. Artificial intelligence about what? That what is the domain of that knowledge. So you will need a domain expert in that domain that you're trying to develop an artificial intelligence on, or else you'll be developing rubbish. So you have a domain expert if you want to talk about, let's say you are trying to do some sort of about economics, you need experts in that field who would, donate his own knowledge of expertise in that domain. If you're talking about trying to do some sort of automation in mechanical system, though you need a mechanical engineering or mechatronics person who understand the theories behind that, who would donate his expertise, and then you can, you have, like I said, the point I'm making is that it's an interdisciplinary domain. It's not just one domain. Everything comes together. All right. So computer science is not just, artificial intelligence is not just about computer science. Even though what I'm putting here is computer science. So you can put here AI as a subset of data science, and then data science put everything together. You have the computer science, of course, which donate its programming skills, the algorithm, how to write algorithm. That's what the guy donates. You need mathematicians or statisticians who donate their crunching ability of talking about data in terms of statistics and all of those things like that, and how data should be grouped, different type of statistical analysis and all of those things like that. You have a domain expert in that. And then, like I mentioned, the problem, because AI is useless except it solves a problem. So the problem you're trying to solve, you also need a domain expert in that knowledge. So everything put together is what we talk about, the data science. So and then AI is in it. So if we are not extracting AI from that parent knowledge of data science, and then we've spoken about what AI is, so I'm not going to bore you again. You can recall AI is intelligence of machine rather than the intelligence of human. The ability for a machine to have the cognitive behavior of human, being able to, gather knowledge, and then act based on the knowledge gathered in the right context. Now, the way artificial intelligence works in two ways. We have one that we call pattern recognitions and pattern matching, and there's one that we call image processing and image matching. It's interwoven basically, so you don't get me twisted, because you see us using them, interchangeably. But basically, the way machine works and the way the computer was developed before now is pattern matching. It's true pattern matching. This is how computing works. If you go back to how the theories of computing itself. So, but this is how AI is broken down. We have pattern matching and pattern recognitions and image processing. Now, from this image processing and the pattern matching, we can group AI into two. And what do I mean? There's no AI without knowledge gathering. For a machine to be able to have the intelligence and have the knowledge, it needs to be trained. It doesn't fall from heaven. You cannot just build a machine today and say, okay, what is my name? Or you just develop something and you're asking that guy what you're asking ChatGPT. You say, what is you are asking that guy. If you have not trained that machine, you won't know it. ChatGPT has a lot of trained data. It has a lot of data in its memory that is using to answer your question. Just pretty much like human brain works. If you have a newborn baby who has not assimilated anything, who doesn't know anything, ask them anything, they don't know. So they only respond to you based on what they know, maybe their previous knowledge, the previous data they've consumed and what they've been able to store. So, and that's how human intelligence works, and the same way the machine works. For machine to be able to be as intelligent as possible, it needs to be trained. So the process of training a machine to be intelligent is what we call machine learning. Machine has to learn. The process of training a machine to be as intelligent as possible is machine learning. That process, teaching a machine to be able to gather the knowledge. Now, there are different ways machine learns. Maybe it learns through statistics. For instance, pretty much like human also learned. Is someone raising their hand?
Yes, please. I did not get the definition of that machine learning.
Okay. Now, we said artificial intelligence is a process or a phenomenon whereby we have an intelligent machine rather than an intelligent human. And ability of a machine to have the cognitive behavior of human, is that. So, remember that we defined what intelligence is. We said intelligence is the ability to be able to acquire knowledge. You acquire knowledge, and then being able to apply that knowledge and make decisions based on that knowledge acquired in the right context. That is our definition of intelligence. Now, for machine to be intelligent, it then means that it needs to also acquire knowledge. How does it acquire knowledge? How does machine acquire knowledge? It needs to undergo training, just like human also. Human acquire knowledge through training, and part of it is why you are here, trying to understand how AI works, so you can, apply it in your various fields. I understand that here we have mechanical engineers, we have computer scientists, we have economists, we have different type of different professions in here, especially when the house become full. We have a lot of profession here, so everybody want to apply it in their respective fields. So for the AI to be intelligent as we want, it needs to undergo training. Blessing, do you agree?
Yes, sir.
Yeah, so the process of training that machine to be intelligent is what we call the machine learning. Machine is learning. At that moment, machine is learning to be intelligent. Do you understand? The process of training machine or an artificial being to be intelligent is what we call the machine learning. It's a process. You understand? So there are different ways you train, just like there are different ways humans learn. So machine have the way they learn. All right? So there are different way of learning. So to see that most of the things that we have on the right hand side there is talking about learning. So machine can learn through supervised data, as you will see later on. And supervised data can be from statistical data. Maybe from history, we know, let's say I build a machine now, I build an AI, and I'm training the AI. I tell the AI, my name is Kenny, and I say that I come from so, and I have so number of siblings and something like that. You're giving the AI some data. You're training the AI. So once you give the AI the data, you can then ask the AI back what you have given it. So what is my name? The AI can tell you what the name is and all of those things like that. But process of training this thing is also is something that is very long, and we'll see it later on. The process of training and the various way of training it, the advantage of one over the other. But here, the context that I'm trying to achieve here is for us to be able to understand at least one terminology from the other. Most of us don't know one from the other. Maybe before now, when you hear artificial intelligence, your mind goes to robotics. Maybe that's what you see. And I think when I ask the definition, some of us mention robotics. Some of us would mention something, that comes to our mind when we hear artificial intelligence. So what we are trying to achieve here is to ensure that we understand to a reasonable extent each of these terminologies. Please, am I making any sense?
Yes, sir.
You are the
Yes,
only
you
one
are.
talking. Nobody else talk. Looks like I'm not making sense to some people.
Yes.
Yes, you are. You are making sense.
All right. Thank
Yes,
you.
you're making
Confirming
sense.
that. So we have the statistical learning. This doesn't put everything into proper perspective. I think the next slide would help more. in terms of learning. So the machine can learn from data. So this here learning from past statistics. For instance, even the way human also learn. If you are going to make a decision about working in a particular environment, you want to take the data, you want to take statistics of what are happening in that organization before. If you're going to put your kid in a school, you want to know maybe this school they perform well in external exams or the trends. So what you're saying is you're making decision based on the statistics that happen in that school. So you can teach this to machine, and the machine can make decision based on that statistical data. All right. So you can have that that kind of teaching machine that, and then you can have from statistical data. You can also have search recognition, which is of course search recognition is vague in this context because you can have different type of search system. Is it text search? Is it voice search? Is it video pattern matching search? Is it image search? You can use image to search another image with the help of AI now. So, but what we're used to before, you have search, like a text search, you go to Google, search whatever, and then this come out. And then the conversation that you mostly have with and maybe GPT have too, you just have a text conversation and the guys generate search. So the search can be any of these, but either of these, either search, either voice, or image matching or video matching, would of course be based on what the guy already know before. So there has to be a way you teach that process to it. Maybe you are going to have some pattern matching, like you see human being looks like this. You don't necessarily have to define this thing, so you can define that how human being should look. So when he sees image of an human, you can say, okay, because it has this, yeah, this is a woman, this is a human. Just pretty much like what we learned in elementary biology, where we have characteristics of human beings that enables us to easily recognize what human is. The same thing with machine. There's nothing comes with magic. Some of us see this like magic. Nothing comes with magic, but where magic is in this deep learning. There's a real magic in deep learning, really, because the machine is able to learn beyond what he was taught originally, beyond the data that he was given. Is able to expand his knowledge just like humans do. Some of our relatives or some are younger ones or our children know some things better than we do, even though maybe we are here before them. That's because they have exposed themselves to more further knowledge and they know better. So the same thing with machine. So as you trade them with the basic data, but they're able to learn every day based on what they are, based on the inferences and all of those things, and then expand their knowledge. But that didn't come until we have deep learning. And deep learning, it bases its learning process through neural network. I mentioned earlier, neural network is the real deal. Deep learning is mostly through neural networks, artificial neural networks. There are several artificial neural networks like recursive neural network, convolutional neural networks, and name it like that. So this is where we have the real advancements, and most of the GPT's applications, the Google is deep learning. And so what you are seeing here is neural network. This basically work with neural network. Now, so learning also, when you're teaching machine, you have natural language processing, which is also some sort of data that you give to the machine, so they're able to easily translate one language to the other. And in terms of this, your machine is able to learn like 5 language or 10 language and master them in a day. All the linguistics, all the terminology that it needs to learn in a distance. Human cannot dare to do that in terms of these things here. So when you have NLP, that's natural language processing. Natural language processing can come under deep learning. When you apply deep learning, it is faster. All this one here, you can use deep learning to teach machine. If you use deep learning, it's faster because it's like magic. But you can use the natural way without using deep learning, just giving them the data and then processing the data like that. This way, but everything that you achieve with just the straight line approach can also be achieved here. You can teach a machine a natural language processing with a deep learning, and like I said, it works pretty much like magic. We will see that most of the things will become clearer as we move along. But what I think we should be able to know now is that what AI is, what machine learning is, and knowing what deep learning is. Deep learning is a subset of machine learning and is a way of teaching machine through neural network. So there are a lot of other statistical learning here. When we talk about supervised, unsupervised, semi-supervised, or substance type of learning, these is where they belong. All those type of reinforcement learning, all those guys. This is what these three guys belongs under there. Now, where does robotics comes? Where does computer visions come? Even though you can have them, all of them, like I said, is interwoven, but you can separate them in terms of symbolic learning. So symbolic learning in terms of physical learning, motion, tractions, and all of those things like that, because this deal more with physicality, right? But like I said, all of them they have intersections. Both of them have intersections. So if you want to teach in mechanical engineering, they have a lot of machines that they use for machining and all of those things like that. And instead of having human doing that machining, turning whatever from one position to the other, you can actually teach that to machine. So when you teach that to machine, you teach them what distance to move, to do certain operation, how to do certain things like that. And of course, this is why we can have AI now doing surgeries and all of those things. The advancement that we've got in robotics, this is symbolic, rather than the abstract text is symbolic. So AI in the symbolic learning, pretty much parametric learning in terms of motion, in terms of techniques, in terms of deep drilling and all of those things that we'll see as we move along. We call that symbolic learning. And of course, all of this machine has to learn is still machine learning. All of this machine has to learn. So the process of teaching machine, whatever you are teaching the machine to learn, is machine learning. So if you are teaching machine a pattern, it's learning. Or you are teaching machine symbols, it's also learning. All right. So, but in this angle here, in terms of symbols, techniques and all of those learning, this is where we achieve robotics. But you agree with me that both of them have intersections. So when you hear robotics, you don't begin to say robotics, what is different between robotics and AI? You should know that robotics is a subset of AI, and in terms of, we achieve this through symbolic learning. And like I said, there has to be a subject matter domain, the subject, a domain expert, who knows what you're trying to achieve, in theory, and then who donates that knowledge. And then we have someone who is very good at programming, and we have people who knows how to write algorithm, and all of this they all come together and then put everything together and then achieve what we are having here. So there's no one line cut it through, but the knowledge has gone so wide that we can actually achieve something without knowing too much, because they are pre-trained model. Through pre-trained model, we can achieve something without knowing so much. So you can do something in terms of mechanical engineering without being a mechanical engineer, because they are expert donated knowledge that is already existing. So you don't have to go get another one, and in fact, a very good one. So you can take advantage of that and be able to do stuff within that line. You don't have to be the best statistician to be able to do an AI, because they've done a couple of things that needs to be documented has been documented. A couple of models have been built. You don't have to build everything from scratch, but it makes sense to be able to know how these things are built. So just in case you have a particular knowledge that you want to document yourself, you know how this thing is done. But most of these things have been documented in medicine, in engineering, in social sciences. Most of these things have been documented, so we can just take advantage of them and just use existing models and just boom, 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 you can get things out. So I don't know if there's any question before I move on. So in that slide, I know I made some noise. I don't know if those noise make sense enough for you to be able to extract meaningful information there. And this is also part of data science, being able to extract meaningful information from noisy data. So I made some noise in the last slide so much. I know some of us will be able to extract some facts in there and be able to understand certain things. But if you still get it pretty clustered, this should clarify things to you. What machine learning is in terms of literature is a branch of artificial intelligence and computer science that focuses on the use of data and algorithm to imitate the way the human learns, gradually improving its accuracy. So human learn by acquiring more knowledge, consciously or unconsciously, just as I've explained initially. So imitating that and teaching that to computer to be intelligent, because intelligence comes from learning. There is no two way about it. Of course, there are people who have we say some guys are smarter than the other, but smartness is actually achieved through a lot of learning. So the more your machine is able to learn, the more intelligent it becomes and the more better decision it's able to make. And that's why even up to tomorrow, even the ChatGPT that you have still gives wrong information, wrong distance, because it doesn't know with certainty a couple of those things. But it works day after day to fine tune and fine grain its knowledge and it becoming a bit more accurate. So if you ask a certain question first time, if you ask again, the second answer might be better than the first one you gave. So, and that is how things really work. So these ones are theory. All these ones are theory. Like I mentioned, is for us to have the theoretical background so that the practical will make sense. So when we are talking about supervised learning, we don't start looking at what is supervised learning. We don't even know what it's talking about. When we're talking about natural language processing, you should know what I'm talking about. But like I mentioned in the other slide when I was trying to explain, I said a slide ahead would clarify things further. And this is where we are. This should put things in proper perspective. This throws more light about machine learning generally. So machine learning is the real deal that makes machine intelligent. So the emphasis is on how machine learns. And of course how human also is intelligence. Emphasis is on what human consume. What we consume effectively dictates how intelligent we are. All right. So for some of us who are born and raised in this part of the world, of course there's a research that says that we are slow in reasoning. It's not about being painting black nations of these things, but it's just the way our environment is. We're slow in the way we talk, because that is influenced by the way we reason. Everything is little by little. Our judgment at the end of the day might be better, but the way we reason, it's very slow, and this informs how we talk, very slowly and all of those things like that. In some other part, they reason very faster, and talk pretty faster, but the talk doesn't mean that it's better than what was spoken slowly, but it's just saying that the speed of reasoning. And I'm saying that the way we consume information and the environments, pretty much affect that. And the same thing applies to machine, because we pretty much clone what we know as about ourselves into machine. and then like that. So I think we've mentioned that in the previous slides. Umar Abdulaziz say he wants to go and pray. Please feel free to go and pray. We had a meeting. We had a break earlier, so we're not going to, after the distance, whoever, we're not going to declare, I'm sorry, Mr. Abdulaziz. The first prayer, the first meet distance. So please go up, feel free and go. But I'm sorry, we are not going to wait for you. All right.
Okay.
Hello.
I was asking for you.
What? I can't hear that.
I was just saying the video has a record.
Yes, we are recording. I hope.
Are you recording this meeting?
Yes,
This
it's
meeting has
being recorded. It's being recorded. Thank you very much. All right. So, machine learning can be subdivided. The way machine learning can be subdivided into this, we have supervised learning. Pretty much like you supervise how your children learn. So you tell them this one is this one is that, this one is this one is that. You supervise it properly. This is wrong, this is right. But you're able to do that to a reasonable extent. After a while, you cannot keep up with that, even human. So the same thing with machine. When you're teaching them, you say this one is like this one is like that, and so they learn through that. But that becomes pretty difficult to be able to keep up with. How long are you going to be teaching a machine and saying that these guys are sick? Let's say you have data in medicine, you're trying to categorize data and say if you see this kind of symptoms, it means that the person is sick. If you see this kind of symptoms, so you are trying to be very, very specific. That is what supervised learning is about. When the data has proper labels, and machine learn with that labeling, with that very explicit, comprehensive data, with everything having how to identify them. So that kind of, when you give machine that kind of data, it is called supervised learning, because everything is very categorical. That's in real context, that's what I've put it. So couple of algorithms I used here. We use supervised learning for regression analysis, different type of regression, maybe linear regression, whatever regression, all sort of regressions that we will see. We use supervised learning for that. For prediction, if you want to predict failure in certain machine, or you want to predict forecast sales, or you want to forecast stock, you just don't want to predict something. So it has to be data before you can predict correctly. You have to know how the market performs in the past couple of points, so that you can predict the future with that. The same thing with failure prediction also. You have to have failure data so that you can predict appropriately the failure in the past, in the future as well. So we use supervised learning for that, but I'm not saying that all this prediction can only be done through supervised learning. No, but basically we use that. We can predict with even unsupervised learning and any other one, as we will find out. So it's also very easy to do classification with supervised learning, since everything has label. So let's say we know that this one is they have labels, like in this place now we have people who came from different backgrounds attending this training. So some of us are, maybe when we ask us to fill the data, you put in your profession. So these guys said he's an engineer, this one says is this one says is that. So we can completely divide people into groups based on the data that they provide, based on their profession. So we can classify. We can easily do classification based on data, since they are very well labeled. So classification is very easy like that. Classification in terms of also the image recognitions also. Let's say we have a lot of images, so we can look at pattern matching and look at these things. So provided the data is very labeled, is well labeled, so we can recognize image and try to separate them and say that, okay, this one falls into this place, this one falls into this place, like that. That's what classification is about. Classification is what we use to, pretty much like what he said, what he says, being able to divide data into groups based on certain parameter. So this data can be raw text, it can be an image, it can be video, it can be whatever. So you can classify that. And this classification is also used to check if something is a fake, deep fake or not, because there's a pattern that we're trying to check for. So you can classify that based on that. So supervised learning should be very clear now. When you have data very explicit and very explained and everything has labeled, that's supervised learning. You give that data to machine, because everything boils down to data at the end of the day. So unsupervised learning has to do with, now things are a bit clustered. You don't know what is right from wrong, so you just give this data to machine to be able to make sense by itself. And this is, like I mentioned, this is how human intelligence also work. At some point, things becomes a bit confusing that we don't know. So we just begin to now see, okay, how do we know what is right from wrong when things are not properly defined? And especially when we say that if we bring it home to Nigerian context, in the last election, where a lot of people said the election, this election, in their language says that this election is the worst in the history of the nation. So how do you clarify worse? What is the context? Or if you want to say it's the best, what's the context? How are you classifying it to be the best? There has to be a criteria set, for you to be able to know that, okay, it's this thing. So there is something that you're watching out for, even though there's no well-defined parameters to be able to know that, okay, this one is that. So we cannot, that's why it's not a fact. Whichever side you support is not a fact. Whether if you say he's the best in the history of the nation, or you say he's the worst, it's still pretty much based on your own perception. And this is sometimes what we call unsupervised learning, because the data is not categorical, so we cannot really say categorically. And the machine will face this kind of data as well. Machine will face this kind of data where data is not well defined. And we have this clustering, data clustering, of course, in terms of in big data, where you have things that are just scattered here and there. We don't know these things from that. Clustering applications, dimensionality reduction is also there, which very much used in robotics, and of course in self-driving cars, all those things like that. Unsupervised learning is used a lot in self-driving automations. Then semi-supervised learning, it's a mix of supervised and unsupervised. So when you have some data are labeled, some are unlabeled, in between. Some data are very well defined, some are not at all. So your machine would also have to learn from such type of data pool. So the techniques that it uses here, and some algorithm that is used here. There's a clustering algorithm actually, and here you have self-training. I mentioned that unsupervised learning, like automations, self-driving cars, self-driving machine, bicycles, all those things uses unsupervised learning. Of course, they will equally use semi-supervised learning. So what is applicable here is also applicable here. Is pretty much a mix of the two. So we have what we call low density separation model, which is an algorithm. We have a lot of graph-based algorithm that is used for semi-supervised learning that we can use. So when you are faced with such data, So you just pull up the appropriate algorithm and use. So this some of these algorithms have been defined, and that's why I'm saying that we don't have to reinvent the wheel. The achievement that have been made, we can just build on. So all these algorithms are available. So it's just for us to know which one to pull off and use at the right time. So when you're faced with this kind of data, you know that this one is more appropriate. This one of data, so you cannot use for unsupervised learning. For instance, you want to use a linear regression. Of course, in certain instances, if you are applying deep learning, you can still use linear regression analysis of that. Is someone raising their hand? Okay, I think people are joining in and going out. It's fine. So reinforcement learning has to do with how you train. Hello, please, can you see my screen still? Sorry, I got disconnected from this place, so I'm trying to share back. Okay, I think I'm back now. Please, at what point did I get disconnected? I think the class is pretty boring, so
Hello, sir.
yes. Please, at what point did I get
You were
disconnected?
you were talking about the semi-supervised learning,
Oh,
how it's a combination of the unsupervised and the supervised learning.
okay. Yeah, so I said that it's a combination of when you have some data that are very categorical and some are not well labeled. So you have semi-supervised learning to approach to train your machine, and there are a lot of models along that line that you can pull off and use. We'll explore a couple of these models as we move along, but the point is that most of these models are available, and of course we can write based on the context. We can write from scratch, but majority of these models you don't have to reinvent the wheel. The models are available, and in fact they have been minimized in terms of there are frameworks that you can use these days that you don't have to reinvent the wheel. Just focus on what you want to do, focus on what you want to achieve, and trying to reinvent the wheel. But it is, if you want to participate really well, depending on the level of participation that you want to have in the field, if you want to just come and be able to just apply, or you want to be an engineer, so if you want to be an engineer, you may want to know the nitty-gritty of a couple of these things. But of course, in the course of this training, we would get to understand certain concepts to a large extent. We'll be able to know a couple of things, and then of course training continues. All right, so that's a bit of semi-supervised learning. Reinforcement learning is pretty much how you train the animals that we have, like how you train dogs, or how you train any other animals that you have, like cats, because they are not like human. You have to train them by reward and punishment system. You have to train them by reward and punishment system. So if they get something right, if you're trying to teach them how to do something, if they get it right, you reward them. And so if you reward them, they would know that they need to do more of that. So when you do that, what you're doing is you are reinforcing the knowledge. You are letting the person know that he has gotten it right. That's how you train animals. That's, if you see people who train dogs, that's the tactics they use. And they equally have human beings who are disabled, whose neurons are not well formed, like people who have autism. They equally use reinforcement learning for them. If you are trying to teach someone, like speech therapist, they use that. So when they get something right, you try to clap for them or let them know that, let them feel good about themselves. You reward them, and then when they do something wrong, you'd also show a kind of penalty. It may not be severe, but of course something that's to show that it's not right. So reinforcement learning is used a lot for robotics, self-driving cars, and all things like that. When things are right, you reward them. So the reward in this case now, you cannot give machine money. It's not human. You cannot do this, but you do something that has to. You have a classification within the machine. There are things that makes machine like it's positive. It receives as positive stimulus, and there are things that it receives as negative. So when it receives that negative, it knows that it needs to do less. It needs to do less of certain things like that. So this is reinforcement learning, trying to give rewards or punishment based on the distance. So, and a lot of algorithm on that, Monte-Carlo analysis, heuristic methods, and all of those things. We'll explore a couple of them as we move along. Because if you look at what my colleague she mentioned, this day we'll talk about supervised learning, this day we'll talk about this one. So each of these days we'll take on each of these and do practical about them. So we have this reinforcement thing. So this is the big deal, like I mentioned, deep learning. This is where all these your generative text generations, image processing, voice recognitions, all those things come along within the deep learning. So this pretty much uses neural networks, like I mentioned earlier, artificial neural network, so to speak, to be able to mimic the human neural system. And then so there are different type of it. There are convolution neural network, which is artificial. We have recursive neural networks, which is a bit of recursion, a repetitive kind of neural networks, and so you get things. I will throw more light on neural network as we move along, because I know that a couple of us are getting bored. It's theory. It's theory. So this pretty much just reinforced what we discussed in the previous slides, and pretty much putting things into grouping perspective. So you have machine learning here. And in the machine learning you have supervised learning. So I won't want to repeat myself. A couple of these things I've mentioned in the last part. You will have this slide. So in supervised learning you have like image classification, fraud detection, customer retention by looking at what customer like and doing more of that. In diagnosis, whether human diagnosis or machine, you can have that. Forecasting, which is pretty much like prediction as well. Process optimization, and then of course deriving insights into data. Supervised learning is very handy, so to speak. But like I mentioned, it's not like you can do all of this with unsupervised learning, but it just takes so much more. You can do them easily with supervised learning because things are very clear. Without supervised learning, you use clustering algorithm, and you can get customer segmentation, get target marketing, big data, all those things coming within here. And then you have the reinforcement learning, like I mentioned, which is about trying to do reward system, real-time decision making, game AI, learning tags, all these things come within this fold. These are just to give certain example. There is 1001 application of AI, and of course it's keep on growing. This one talks about the supervised learning that I've explained, so it's not going to say anything different except less of what I've said. And I've also mentioned this about classification. When you have different type of image, So you can use a pattern to classify an image and know that, okay, in this place, even though we have plenty of them, you can see how they look by their pattern. You can use that to group and say this one is like this. You can see this one how they look, because they look pretty similar. This one is like this and this one like that. And you can then, so if you have a predefinition of how apple look, and then this guy can talk about apple. If you have something that maybe you based on color or based on shape, you have a predefined parameter. So the guy can say, okay, it's an apple. This guy can say, it's a pear or whatever, avocado, whatever. So this is about just a pictorial explanation of what I've spoken to. All these ones I've spoken to them. The supervised learning, I've also spoken to it. Classifications and regression. The supervised learning, you have neural network, naive Bayes. These are different algorithms that are used. Logistic regression, very used. Support vector machines. There are various algorithms that we use. So we apply each of these algorithms based on context. What is most appropriate to be used for this thing. So challenges for supervised learning are this. You need expertise, because for you to be able to know how apple looks, you must know how apple looks. So for your machine to know this is going to be an apple, someone has to train it to recognize apple, and that is not always available. So getting expertise is a problem. It's time consuming, because how long are you going to continue to do that? How many things do you want to teach your machine? This is how this one look. This is how that is. How many can you do? It's time consuming, and you don't pretty much have time for that. And the whole essence of AI is to, of course, make your life easy, not more difficult. Supervised learning is also sometimes can be prone to error, because you can have, since your machine is already relied that this data are categorical, what if there are errors? What if the person that you call expert is not really an expert? What if the data is wrong? You understand? So this is pretty much prone to an error or to errors. Then it's training dependent. It's relied solely on you have to train me to learn it, and people don't want people like this, even human. You don't want people that you have to train them to do everything that they do. You want people that can go out of their way and be able to learn things and apply it. That's the kind of machines you want to build. But if your machine is just solely, or your AI is just pretty much on supervised learning, then it relies solely on everything that is taught. It cannot learn anything by inferences, by deductions, and all of those things. Everything has to be very clear and categorical, and that is very disastrous. So these are challenges of supervised learning, though of course it's easier to work with, because things are a bit categorical. Unsupervised learning, I have explained it. When things are not clear, the data are unlabeled, clustering and association. So these are algorithm, clustering and association algorithm. Challenges accuracy measurements. It can be very difficult to be able to know what is right and what is wrong. So if you don't know what is right and what is wrong, how then can we decide or say boastfully that what we have is correct, if we don't have a predefined parameter of correctness? So it can be very difficult to get. And so unsupervised learning have this challenge. Lack of guidance. Also, there's also a problem. Even though we want you to learn, we want our machine to be able to learn on itself, it's a challenge when machine don't have how to learn and what to learn, stuff like that. So it's a bit of problem, and it's pretty much like it's a problem to human, it's also a problem to machine. If you are in an environment and there's no guidance, you don't know what to do, you're pretty much confused. You are pretty much confused, and the same way your machine is even more confused. So it's a problem on unsupervised learning, because he doesn't know what to do, how to do stuff like that. But of course, the algorithm that solves or minimizes or mitigates such a challenge. Sensitivity to data quality. The brilliance of your artificial intelligence is a function of the data, the quality of the data that it has. And unsupervised learning have, very high sensitivity to quality data, because we don't even know what is quality. You understand? So, but in terms of big data and all of those things, we don't have an option than to learn through unsupervised learning, because this allows us to learn volumes. So there's a lot of research going on in terms of data quality to be able to ensure that when machine is learning through unsupervised learning, they learn by removing. Not all data are important. Not all data are important. You don't have to learn everything. You have to remove, being able to, for machines to be able to know what to learn from data. Just like what we have been talking about since morning, or since we started. Not everything would be. So some of them are just inferences, just by way of explanation. Not all of them are pretty much equally important. So when you have data, when you give machine data, machine should not want to learn everything. Ability of a machine to be able to know what to learn from data. That's what is going, research that are going on in terms of data quality. To know the quality part of data, so that machine can just master those parts and what is important in the data, and then just throw out all those things that are not so necessary, and like that. And then scalability is also a problem in terms of machine learning. In terms of computation. So because we don't have proper parameters, so how then do we scale? And all these ones are there for it. Semi-supervised shared everything about supervised and unsupervised, so I'm not going to bore you. I've explained this one also as well, that semi-supervised learning is an intersection of supervised and unsupervised learning, so there's no much more to talk about. Reinforcement learning, I've explained it, so this slide is not going to talk more than I've explained, except it's going to say less. Deep learning, deep learning, I think this is where I will slow down a little bit and try to attempt to say more, though we are spending out of time. This class should end 8, and we want to be sticking to time, but of course you agree with me that we started a bit late today, so I will just extend a bit. But the activity that we have next, which is setting up our environment and installing tools, we can delay that to tomorrow, and so we have that taking first time, since we don't even have the full house. Some people are complaining that they didn't get the email that was sent, so we try to see how we can carry them along so that they don't lose so much. But I haven't said that I'll still finish up this theory. So deep learning attempts to mimic the human brain, how a human brain works, and until this was actually done, all the AI that we're doing were just like child play, just small child play. But until deep learning came into play, it was not that okay, this is real intelligence. So it attempts to mimic human brain through combination of data input, weight, and bias. So everything, that's how we make the additions, is about what we have experienced in the past. I was talking to someone about certain things, and the person was saying that maybe he has a problem. It's what we spoke about is pretty confidential, so I'm not going to be able to mention the specifics about what was spoke about. So, but the person was saying that maybe he has a problem in terms of making decisions. Maybe it's his own personal problem. And I told him that as a data scientist, I agree. I can say that he doesn't have a problem. This is how human work. So this is how we work, whether we like it or not. Our decisions is shaped based on our experience in the past, and our experience in the past is the data that we have at the back of our minds and our brain. So we make decisions based on that. So, and that experience that we had in the past, of course, shape our bias. So we have some sentiment, certain sentiment with certain things and all of those things like that. So, and this also influences how we learn, and how we learn also based on our bias, something like that. And so, as much as possible, people say keep an open mind. But even when you keep an open mind, you still bias. For instance, if you're talking about, I don't want to go there, but I can go there, since everybody here belong in one religion or the other. The way a Christian will read a Muslim context, a write-up by it that is so Islamic, it won't be the same way that a Muslim will read that same context. And the same thing applies vice versa, because of our, sentiments of beliefs and all of those things like that. And there's nothing wrong about it. This is just how we are shaped. And the same thing machine should learn. Machine will learn based on input, weight, and bias. If you are going to train a machine through a neural network, because this is how human brain works, through input. Inputs can be a text, like raw text. The primary way we feed input into machine is that. But human brain, inputs is several things. The way, before I can interpret what I see, I have seen it first. So it comes as an input, as an image, and then I process that, and then I now interpret it and say this is what it is. So a machine can also learn through just image. You can just give an image to a machine, it learns that, and then it processes it, and then it interprets it. So you have inputs, but everything would be transformed into 1 and 0 matrices formats, or whatever. So an input can be a video, it can be a text, can be a voice, can be anything. So we transform that into the format that is taken into the computer. Would look at the weight of that thing, and that's the weight in terms of the importance of that. So we look at the weight, and of course we look at sentiments and bias. We'll see how this thing works as we move on. So this is how artificial the neural network works. So the human neurons works, like I said, human brain has like 100 billions of neurons working together to achieve results. So the guys that developed this in the 50s also developed a neural network that you can have billions of neurons working with billions of neurons to be able to process stuff. Of course, neuroscientists and all things, everyone came together to be able to achieve this. So the neural network works in layers. So if you hear something about layers, so everything together here is called model. So you have an input layer, which is where it takes the inputs, whether the image, whether video, whether text, or voice, whatever it is that is going to take, it takes that. And then there is going to be a lot of intermediary layers. So intermediary layers can comprise of several neurons. So all these boxes here are pretty much like neurons. So one layer takes the input, and then you define how many layers you want to have in between with the number of neurons that you want. And then when this layer finishes their work, they pass into another layer, lot of neurons, and then eventually when they are done, we're getting close to what we want to see, then they pass it into the output layer, which eventually give what you have. This is the back end of your ChatGPT, all those things that you see. And when we keep working, you will see how things really work. It's neural network. Because before human sees and interprets what he sees, it's not a joke. A lot of things going on within the neural networks. And when someone ceases to see, there's something also going on within the neural networks, of course, with the couple of part of the eyes that's responsible for that. So there is a dedicated session where we talk about each of these sections: supervised, unsupervised, deep learning, and then we'll revisit this one more time, where I'll be able to, or where we would be able to, have a deep dive of this, of course, with practical. So it makes more sense that time. What we are doing now is just to lay some theoretical background, so that a couple of things make sense as we move along. All right. So type of artificial neural network: perception, field networks, all these ones. There are different type of the neural networks available, so you can have them. You have those common applications, aerospace, autopilot aircrafts, that we're having now. You can have just develop whatever can fly. you call that whatever artificial name you want to call that, and then you can use that to spy, uh, maybe the militants. You can use that to, so aerospace, you can have an aerospace that can drive itself without human. When military goes for war, and then you have someone in the plane, it's when they hit that target, you put the person in danger. So, but if you can have um, pretty much like a bot or stuff that's or self-driving automation or aircrafts, they can go on that mission. It becomes pretty easier that no human, even if that is brought down, no life is lost. So you can have that. You can use that to spy whatever you want to spy. So you have, I think I lay emphasis on military. I don't know what I was putting this is, but there's a lot of more applications, because most of the things here we're talking about. So you have in medicine, you have a lot of it's now seriously being used in medicine. Yeah, but it's not just in medicine. Everywhere in medicine, they are using it to do self-diagnosis. They're using it to do surgeries, and to be able to do a whole lot of other stuff like that. Speech recognition, everything is interwoven. Speech recognition is just a variable in itself, and is applied in several ways. You can use speech recognition to detect fraud. You can use speech recognition can also be used in language translations. But speech recognition, of course, it's an advancement through the neural network, and like I'm saying, that neural network is a real deal. Language translations is also through that. So the company that put this together is called K Solutions. It is not through any sponsorship. It is just solely based on our own corporate and social responsibility and trying to contribute to the community. All right, so of course, this is our website. We have a phone number, and then we are available on social media. You may want to follow us, and of course, I would want everybody here now, if you haven't been following us, please do so here. And then this last part, of course, this is the X, or what you call Twitter, at K Solution NJ. Thank you very much. I hope, of course, we've been able to learn a couple of things. Things will become even clearer as we move along, as we begin to apply them. Thank you very much. So I would want to entertain questions. Then we are supposed to have the second leg, which is setting up our tools, but I would want us to suspend that as an activity that will be done tomorrow. That is that. And again, we added you to a Slack channel. Please check your email. You should have that invitation. Join. This slide will be shared in there, and the recording that is being that we have also would be shared in there. We would also be sharing a WhatsApp link. We'll be sharing a WhatsApp link. So once you receive that, join. We may not send an email again because people said they didn't get an email, so we may want to find a way to automate addition to the channel, to the WhatsApp channel. So we'll do that so that people who didn't receive email would see themselves in the, because here we didn't even see up to 20% of the attendance. The fact that people didn't we're receiving some messages that they did not get emails. All right, so thank you very much again for the audience, and of course for having interest in AI. Together we would build the next generation of artificial intelligence. Thank you.
Thank you so much for the class, sir.
You're welcome.
Thank you so much. We I really appreciate.
You're welcome. Thank you, everyone.
So much, man.
Thank you. We appreciate.
Thank you,
Thanks so much.
Lukman.
Thank you, sir.
Good night.